Good evening, all. So today we shall start with power engineering paper. In the first module, we have to study about generating stations, electricity generating stations. In this whole paper, we are dealing with generation, transmission, and distribution of electrical energy. Okay, we shall start with our first module. So in the first module, we shall see what is electrical energy and how it is being generated. So energy, electrical energy or energy in any form provides the power to progress. Okay. If we watch the development of a society, you can see there is a close relationship between the energy usage and development of that civilization. So the development index of a country can be decided or calculated in terms of their energy consumption. If we have a close look on developed countries, you can see all their industrial activities as well as agricultural activities are being supported with the help of electrical energy. Basically, there are two types of energy forms. One is the primary energy form, other one is the secondary energy form. Generally, these primary energy forms are mechanical energy forms that are naturally available. Electricity is referred as a secondary energy form that is developed or being produced from or converted from primary energy forms such as heat energy, light energy, potential energy, kinetic energy, etc. Okay, so electricity is considered as a more refined form of energy. Then we shall see what are the advantages of using electrical energy. So first of all, it is the most refined form of energy. It is most clean form of energy. So in order to, when we are using electrical energy for heating, there won't be any ash produced. There won't be any pollutant gases developed by heating of, say, water by means of electrical energy. But if we are using any primary form like coal or firewood for generating heat, there will be plenty of ash generated, pollutant gases will be produced, carbon dioxide will be produced. So, all this makes electrical energy a most refined form of energy. Then, electricity can be generated in large quantities at comparable cost with other types of energy. It can be generated in bulk range with comparable cost with other energy forms. Suppose we have to generate heat, we have to fire the coal or burn some firewood and generate heat. We cannot go to a very large extent for producing heat energy by means of this conventional method. But electricity, on the other hand, can be generated in small quantities, medium quantities, as well as large requirements. Then electricity can be conveniently transmitted over long distance. If you are having some conductor arrangement, electricity can be easily transported from generating station to other load locations over long distance. Then electricity can be utilized efficiently in a number of processes requiring energy. Electricity can be utilized for producing heat energy, light energy. Then it can be utilized in industrial activities for producing mechanical energy. Then it can be utilized for electrochemical actions, reactions, applications like electrolysis, etc. Then it has got maximum flexibility, sensitive, and easy to control. Electricity can be easily controlled by means of a switch. You can switch off, switch on according to our requirement. It is very sensitive also. When we are switching on a lamp, suddenly it will glow, and if we are switching off, it will shut down. Okay, so it is very fast also, fast responding. It is very Then the main features of electricity. Electricity is the backbone of industrial world, and comfort, convenience, and safety of people all around the world depend on electrical power. Now, energy may be needed basically in primary forms: heat, light, motive power, or direct use in electrical processes. On all these applications, electricity can be directly used. Then, electricity, the energy may be needed in large or small quantities, continuously or intermittently, or in various locations. For all these purposes, electricity is very much suitable. Electricity can be availed on a large scale or in small quantities for charging mobile phones, etc. Then it can be availed continuously. For a refrigerator, we are continuously availing electricity. Then intermittently, we can switch off the light, switch on the lamp according to our requirement. Then in various locations, electricity can be transported to anywhere by means of conductors. All these are features of electrical energy. Then types of energy sources. That is how electricity can be produced from primary energy sources. What are these primary energy sources? Then there are renewable energy sources as well as non-renewable energy sources. For bulk generation of electricity, we are using non-renewable energy sources. They are also called conventional methods. Then if you are using renewable energy sources, that will come under the category of non-conventional energy sources. So solid fuels, liquid fuels, natural gas, hydroelectric power, nuclear power, all these are non-renewable energy sources. Solid fuels examples are coal. Then liquid fuels, petrol, diesel, etc. Natural gas, then hydroelectric power, nuclear power, all these are non-renewable, coming under, except hydro. All these are coming under non-renewable energy sources. They are referred as conventional methods of generating electricity. Then there are non-conventional methods also. They are called renewable energy sources. Solar, tidal, wind, geothermal energy forms are coming under this category. So in our paper, we have to study electricity generation on a large scale. So we are going for conventional methods. So we have to study thermal power plant, nuclear power plant, hydroelectric power plant, gas turbine power plant, diesel power plant, etc. in the first one. Then main parts of a power system. In the power system, we are dealing with generation, transmission, and distribution. So we have to study about generating stations, transmission system, and the distribution system. Then in the first module, we are dealing with generation. So before going to power plant, we have to study the general aspects of a power plant. So power plant is an assembly of equipment that produces and delivers electrical energy. So power plant, we are having various types of equipment that are utilized for generation of electricity, and it has to be delivered out in order to meet the law. So power plant is an assembly or arrangement of equipment that produces and delivers electrical energy. Then classification of power plants. Power plants are classified based on various conditions. So first of all, on the basis of fuel use. What are the different types of fuel use? So fossil fuels are there, liquid fuels are there, gas fuels are there, gaseous fuels. Then hydropower is there, nuclear power is there. Based on the fuel use, what is the input to the power plant? The power plants are classified like this: steam power plant. If coal is being utilized as the input, then it is considered as steam power plant. That is, if the primary source for the power plant is coal, then it is referred as a steam power plant. Then if diesel is used as the input, the power plant is referred as a diesel power plant. If nuclear fuel is used, then it is referred as a nuclear power plant. Hydropower is used, hydroelectric power plant. Then natural gas is used when then it is referred as gas turbine power plant. Then the power plant can be classified based on the load, nature of the load. If the power plant is running to meet load that is always present in the power system, then that type of power plant is referred as base load plant. So, nature of load. Loads are generally classified into base load and peak load. The loads that are always present in the power system are referred as base load. So, some hospital loads, UPS charging system, some industrial loads, all these are present for 24 hours in a power system. If we do a daily analysis, in order to meet those loads, we have to drive some power plants that are very much economical to operate in order to meet those loads. They are referred as base load plants. Base load plants will be always present or generating in the power system. Then peak load. Peak load condition is when all the loads, most of the loads are connected to the power system. That is, if we consider the Kerala system, we can see all the loads will be operated during 7 p.m. to 10 p.m. That is, in Kerala, most of the consumers are from domestic side. So, for lighting purpose and for kitchen activities, entertainment purpose, we'll be switching on all the loads during this time, evening time. So, peak load. The maximum load will be occurring on the power system during this time. So, the load is referred as peak load, and some of the power plants may be dedicated to meet these load alone. So, such power plants are called peak load plants. So, peak load plants are connected to the power system or generating when peak load, sudden load demand is there in the power system. So, based on the nature of the load, plants are classified as base load plants that meet the base load. They are driven for 24 hours. Then peak load plants are dedicated for meeting the peak load, sudden rise in demand. And these power plants are referred as peak load power plant. Then on the basis of location, where the power plant is being located. Some power plants are located near to the load centers. Load centers are these residential areas. They can be considered as a load center. Then industrial areas also can be referred as a load center. If the power plant is placed near to the load center, it is denoted by central power plant. And when the power plant is isolated from the load center, that is away from the populated area or industrial area, just like hydroelectric power plants. You know, hydroelectric power plants are available in hilly areas where head of water is available. So, such power plants may not be near load centers. So, such power plants are referred as isolated power plants. In the case of this nuclear power plant also, we cannot locate that near a populated area or near an industrial area. It has to be located away from such areas. So, in that case, nuclear power plant is an isolated power plant. Then, on the basis of service rendered, stationary and locomotive. If the power plant is located permanently somewhere, like hydroelectric power plant, nuclear power plant, then it is called stationary power plant. If the power plant is portable, for example, in order to have a construction in a remote area, we need some electrical power. We will transport a generator to there and do the construction work, and we will bring back the generator. Okay. In that case, the generating system is transported. In that case, the power plant is referred as a locomotive type. Normally, they will be of small rating. So, these are the classification of power plants. Major power plants utilized for bulk power generation. Now, requirement of a power plant. What are the conditions to be satisfied by a power plant, or what we are expecting from a power plant? So, economy of expenditure, that is minimum capital cost and operation and maintenance. That is, the cost associated with a power plant should be minimum. So, general costs that are associated with the power plant is the capital cost, operation and maintenance cost. The capital cost is required for acquiring land, purchase of land for installing a power plant, then constructing the building for the power plant, then purchase of the equipment, installation of the equipment. All these will come under capital investment or capital cost. This is done during the starting of the construction of a power plant. Hence, it is referred as a fixed cost. Fixed cost. So, capital cost is referred as a fixed cost. Then, operation and maintenance cost involve salary of the operating staff. Then, cost of the fuel, cost charge for transportation of fuel, etc. Then, maintenance cost also. This is a variable cost and referred as running cost. So, two costs associated with power generation is the fixed cost, that is the capital cost, and running cost, that is the operation and maintenance. This should be minimum for a power plant. Then only it will be economical. Okay. The second point is safety of plant and operating staff. So, plant should be safe for the surroundings as well as the staff who are responsible for the working of the power. Then reliability. The power plant should be reliable for meeting the load. If the power plant is rated for some megawatts, should be capable of supplying that much amount of power at any condition. So that means the reliability. Then efficiency. As per the input to the power plant, we can provide input as diesel, coal, nuclear fuel, etc. So according to the input fuel, the electricity generated should be high. That is, output should be high with respect to input. So efficiency should be high for a power plant. Then the power plant should not be sent for maintenance for a long time. So that will affect the generation of the generation as well as output from the power plant. It can affect the reliability of the power plant. So maintenance should be done on a fast rate. So ease of maintenance should be there. Then the power plant should provide good working conditions for the operating staff. It should not produce a surrounding and disturb the people living around. So the working conditions should be good for a power plant. Then it should cause minimum transmission loss. This comes when the power plant is located, depending upon the location of the power plant. If it is an isolated power plant, power has to be transmitted over long distance over transmission lines. We know transmission lines are made up of conductors. Even though they are good conductors of electricity, they will be having certain resistance. When electricity is carried over this transmission line over a long distance, there will be I squared R losses. So some generated power will be dissipated out as heat energy in the form of I squared R losses. And the power reached at the receiving end will be lesser due to these losses. So, if the plant can be located near to the load center, these losses can be avoided. Okay. So, minimum transmission loss should be there for a power plant. These are the main requirements of a power plant. First is economy, then safety, reliability, efficiency, ease of maintenance, good working conditions, minimum transmission loss. Then types of laws. Laws that are coming in a power system are residential laws. Domestic purposes has to be met. Then commercial laws will be there, industrial laws will be there, municipal law, irrigation law. Different types of laws are there in a power system. Then main parts of a power system, we have seen that there should be generation. Generated power has to be transmitted over long distance. Then it has to be distributed to various types of consumers at various voltage levels. So these are the main parts of a power system, and we have seen the generation methods. There are conventional methods utilizing non-renewable energy sources such as thermal power plant, hydroelectric power plant, nuclear power plant, then diesel power plant, gas turbine power plant, etc. The non-conventional methods, they are using renewable energy sources, solar, wind, tidal, geothermal, etc. So the first part we have to study in this module, conventional methods. Okay. So in the next class, we shall start with thermal power plant. So we will finish today's class and we shall continue the next class with thermal power plant. Thank you.